There we go.
There we go. So, welcome to the Friday Transportation Seminar. My name is Chris Monsieur. I'm a faculty member in Civil and Environmental Engineering. And together with my colleagues Jennifer Dill, Rob Bertini, John Glebe, and Miguel Figliozzi, we co-organized this seminar. So today we're very pleased to have one of our own faculty members, Dr. Miguel Figliozzi, to present today about analysis of commercial vehicle tours.
Is that better? Okay. So I'll start with a brief motivation about why it's important to study commercial vehicle tours. Then I'll move towards the approach I took, that is mostly analytical approach to do the study. And then I'll show some results. I will not go too much into formulas. I'll try to skip that to go into what is more intuitive about the results. And then I'll focus on congestion, because congestion is a very important issue in urban areas, and we have done quite a bit of research on that. So I'll focus on that, and then I'll wrap it up with some important conclusions at the end. So why is important? Well, one thing about commercial vehicle tours maybe you don't realize, but commercial vehicles are running all the time. They could be far fewer than passenger vehicles, but instead of being used 2 hours a day, they might be used 8, 10, 12 hours a day. And the miles or kilometers they travel end up being quite substantial. So some studies show that in many US cities, it's over 10% of the miles traveled. And the number itself, well, could be not quite impressive, but you have to think also that commercial vehicles tend to be heavy, tend to be slow, tend to be large. So how they affect traffic and how they impact on congestion is much more than that 10%, because obviously, as anyone that is familiar with engineering design manuals like the capacity manual, you will see there are factors affecting commercial vehicles that are usually 2 or 3 times, or maybe 4 times when you have grades, much more than a passenger vehicle. So you can think about this issue, and also, of course, safety. Commercial vehicles, from the safety standpoint, when there is an accident, it tends to be worse than when you have just a passenger vehicle. So I'll bring some news that I like to read all the magazines and news related to freight and logistics, and to see what is changing in the world that affects how companies operate, and then it affects how vehicles travel, commercial vehicles are used on urban areas. So this is just from the news, and talks about UPS extending their time delivery service, so increasing these time windows, making it more number of time windows, so customers now want to have deliveries at the specific times, but it's just not enough to have morning or afternoon. They want to have early morning, they want to have mid-morning, or they want to have early afternoon. So it's getting narrower, and it's getting more difficult for companies to provide this kind of service, because the customers' demands are going up. At the same time, this has been well documented. This issue about just-in-time, about new manufacturing, better use of technology in manufacturing and distribution is reducing inventory sizes, reducing the stocks that company keeps. And this has been observed in many industries, especially in the industries that have high-value products or where they are very time-sensitive. And there has been a steady decline since the 1990s. And the downside of this, well, this is great for companies, is they save the money, but the requirement for the transportation system is that now it's much more important to have reliability and to have companies that can provide services that meet the requirements that go associated with just-in-time production and distribution. And this is not something just that happens in the US. These are some statistics from the UK. And you see this is just one specific sector of the economy, just frozen food products. And you see 95, 98, 2001, and then you had the lead time. So it's how much time companies give suppliers about when they want the orders. And that has been reducing from 6 to 3 days. So they want things faster. The delivery frequency, so it went from, on average, 2 times a week to 4 times a week, so double in a few years. And the size of the consignment, so the deliveries, obviously, if you increase frequency, the demand or the sales doesn't increase that much. The consignment, the shipment size has to decrease. So there was a decrease in the number of pallets that were delivered. So all these things are coming together. So more time windows, more time-definitive deliveries, UPS trying to provide better service, companies going into just-in-time inventory and having more frequent deliveries of a smaller size at a more definite time during the day. So the consequences are, obviously, someone has to deliver, and this is going to impact the tours and the routes of the companies that provide these transportation services to the different commercial sectors and activities in urban areas. So one thing is, to study this is such a huge issue because you need to think about the big diversity of industries and activities in an urban area. So to do some analytical study of this, the properties of distribution routes and tours, I divided commercial activities using 2 main factors. One is the intrinsic value of the activity or product in relation to the transportation cost. And the second one is time sensitivity. How time sensitive is the activity or product that you have to deliver in relation to the planning time that transportation companies have to provide that service. So that's one aspect. That would be the demand aspect of the problem. Then you have the supply aspect of the problem. That is here is for companies that try to deliver these services, you will have different constraints in your routes. Constraints in terms of capacity of the vehicles, the frequency you have to serve your customers, obviously the duration of a vehicle tour. Obviously, drivers cannot work more than 8-10 hours depending the regulation and the law that regulates the maximum number of hours that commercial vehicle drivers can operate without stopping. And finally, something that is very important is time windows. So how many customers or what type of customers will be asking for a specific time windows for the deliveries. So this kind of quickly kind of covers this issue about the demand and the supply. And if you try to match demand and supply, what I come up here in this table is looking here at the commodity or service value in high and low, and the time sensitivity, high and low, and then what type of tour or what type of routing would usually go together with that combination. So the first one, low time sensitivity, low commodity value, is the type of products or services where the product itself in relation to the transportation cost is very low. So they tend to be truckloads. So economy scales are very important in this kind of deliveries. So the type of inventory and type of supply chain is decided to take advantage of truckloads or big economy scale as much as possible. When you go to time-sensitive products, but that they are low in terms of commodity value, so this type of commodities tend to have more frequency requirements. So, for example, could be grocery deliveries. If you think about time-sensitive products, milk is a time-sensitive product. The value of the milk itself per unit of weight or volume is not very high, but you have to deliver often because milk goes bad. So you need to keep a frequency of deliveries, and in that case, what is the main constraint is the frequency of delivery that you have to replenish your customers, for example, 3 times a week, and you could not do this 2 times a month with a big truckload because that would be cheaper, but that would not go with the product you're trying to sell and the service you're trying to provide. So finally, you have very high commodities values and very time sensitive. And this is where you go to more the issue of just-in-time deliveries, so critical deliveries to companies that depend on these small shipments to continue operating, so they cannot stop production just because they are missing a small shipment, or package or direct delivery of expensive products could be, if you think about electronics deliveries, it makes sense to have a courier or to have a UPS or a FedEx delivering these products because the value of the product itself is much higher than the cost of the transportation service in proportion. So this is the kind of combination where you have more time windows, more time of constraints in the terms of the constraint is the time window, not as much the size of the shipment. And finally, you have this atypical combination because it's very rare that you're going to have commodities that are very expensive and that they are not time sensitive, because when you have something very expensive or very important, you want it delivered at a specific time. So going from that, then going from the supply, the demand, it's important to see how that matches in terms of supply of routes. And in the first type, the low combination, you have routes mostly constrained by volume, by capacity, and that will give to truckload routes. The second type will be less than truckload, where the frequency is the main constraint. Capacity is still important, but frequency becomes also very important, maybe more. Then you will go to tours where volume, the size of the vehicle, is not the main constraint, but how many customers, how many stops you can accommodate in your routes, because obviously the more customers you can accommodate, the more efficient it is for you as a carrier or transportation provider. So that's the type 2 tour, where the tour length is the key limitation, because if you stop, for example, half an hour at each customer, then maybe you cannot serve more than 7, 8 customers per route, but maybe you have, as a carrier, 200, 1,000 deliveries to make. So you can imagine roughly that there is this relation between how many customers you can serve and how many routes you would need if you start looking at total customers and average number of customers that can be served per route. And again, the tour length is important, and in this case, congestion and travel time speeds are going to be important, because are going to determine how many more customers you could have or how many customers you cannot have because you are going too slow, so your tour is getting too long, you are exceeding 10 hours, you cannot have a driver driving more than 10 hours, so you will have to make your routes even shorter. And the third time is all of that, but time windows are the main constraint. So when you have time windows, it gets very difficult to have efficient routes, because it's not just the geographic aspect, but the temporal scheduling in time of customers. It becomes fairly complicated, especially when customers are spread out and with very specific delivery times. So to do this analysis, I went to one framework, one model that is fairly common. That's the model of one distribution center or one depot and serving a set of customers in a given area. So that's fairly common in practice. There are distribution centers or depots that will be assigned specific areas of a city or of a region. And the other thing is, obviously, looking at transportation demands and then looking at how carriers will meet those demands given the fleet and the location, relative location between depots and customers. So what I used is something that is called continuous approximations, and it's a technique, and the people are from Berkeley maybe took this from D'Aganzo, and he was pioneering this usage of continuous approximations to study logistic problems and freight problems. And it's very nice to have analytical expressions, because analytical expressions let you understand the system much more than just numerical examples, because you can see relationships between the key variables. And this is just one example about what would be a tour duration constraint, and then what are the main things that go there. So you're able to put in a formula important things like distance to the depot, the density of your customers, the number of routes that you have, the customer time, how much time you spend at your customers, the travel speed. And you can come up with these formulas for all these different constraints, capacity, frequency, and time window constraints. So I'm not going to go through all of them, but just to give you a sense, they're all in the paper, but it's all analytical up to this point. So when you look at the different tours and you start analyzing them, one of the key issues is, well, what's the most efficient from the companies could be not the most efficient from the point of view of vehicle miles traveled and vehicle hours spent on the road, because those are the things that will, for example, impact on emissions and cost that are not necessarily taken into account when carriers come up with their route design. So obviously, one of the things that you could see from the analysis is truckloads are the most efficient way of delivering if you want to make it more sustainable. But obviously, one of the issues is you need to have enough demand for those truckloads to be really truckloads, because there is always one critical ratio where if you cannot consistently fill your trucks, for example, more than 50% or 60% of their capacity, then combining customers doing less than truckload deliveries becomes more efficient, because you end up doing less hours and less miles on the road. And you will be surprised, because in practice, companies cannot fill their trucks that often. It's hard for many companies to do it, especially when you have variations in demand and you have products that tend to be towards medium, higher in the terms of how expensive they are. So you will be surprised, but common utilization in less than truckload from industry experience, and I've done some work with less than truckload companies, you can get sometimes, if you're lucky, 60% of your trucks filled. There are days they go out with 10% of their capacity. Obviously, there are days they go out with 90%. But it's not, in less than truckload, it's not that easy to fill up those trucks. And obviously, it gets to the point there is this critical threshold between what is more efficient, try to use truckloads or try to use less than truckload, consolidate many more customers. That could be more efficient in some time. The other thing that you can get from the analysis is that the percentage of empty trips sometimes have nothing to do with the number of trips. And for the people that do transportation planning, this is important because there are many freight models that they are trip-based. And if you are looking at trip-based models, but the reality is that companies do tours, they combine several customers, you're really looking at the wrong problem. You're trying to use the wrong approach to represent a freight situation that is not happening on the ground. So this is, from the analysis, obviously, that's something else that came out. And obviously, this is also very more technical, but the trip length distribution that some of you are familiar with gravity models, this trip length distribution is important to calibrate the models. But there are some assumptions that, in general, this comes from passengers, that obviously the longer you are, how attracted you are to areas that are far away decreases. But in the case of freight, this assumption doesn't make any sense because the attractiveness of the location is given by the demand of your customers. If your customers are very far away, you will go and serve them no matter what, if they are close or not. So in many models, this assumption is hidden, but it doesn't really make sense because this is not the way companies think. They will serve the customers close and far, and we're going to see at some of this data from real-life distribution companies how this is, happens in reality. So to give more intuition about, well, what changes in some factors, how they're going to impact on changes in the VKT, vehicle kilometers traveled, and VHT, the vehicle hour traveled, that they are not the same, and that's something else. Changes in the distance is not necessarily correlated with 100% with changes on the time that the vehicles spend on the network. And there is something to think about. And here I put some typical changes that may happen in an area and the different tour types, the one starting with capacity constraints, frequency constraints, the duration constraint, and the time window. And for example, if you reduce the vehicle size that can access, for example, a given urban area, the plus saying, well, obviously, the truckload tours will be very, very affected, and they will really increase the number of miles and hours traveled for them. But if you go to the less than truckload that is affected by time windows, they're really not going to be affected at all because, in general, they tend to have smaller vehicles anyway, and they never get to use their capacity. So it's important to see that different changes will affect different types of tours in a very different way. And if you go to limit circulation, for example, making routes longer because you ban, for example, access of trucks to a given street or given artery or given area, that's going to affect truckloads. Obviously, it's going to make routes maybe longer. But the ones that are really going to be affected are the ones that have time windows. And each increase in distance maybe is going to correspond to one customer less or two customers less per route. And that will require the addition of many more routes. So again, the impact totally different in one type of tour than in the other. If you talk about reducing loading zones, or you could think about the opposite, increasing loading zones in urban areas, well, truckloads usually will not be really affected because when you're dealing with truckloads, the deliveries, the consignee usually have the facilities and the layout so you can accommodate the track load. But when you're talking about less than track load and random customers that might change every day and they don't have the infrastructure or they don't have a loading and unloading dock, reducing this will create a huge nightmare for the people that trying to schedule the routes, because it will mean that the driver will have to get out of the vehicle, walk a much longer distance, waste a lot of time, and that will mean that the routes will be less efficient and you will need many more vehicles to provide the same level of service that you had before. So it's again very different across the different tours. And obviously, changes in industry demand, changes in more just-in-time, it will affect more track loads, obviously, because already the deliveries with time windows, they're already small. So any further change, reduction in size, will not really affect them as much. And finally, congestion. And it's important here I had to disaggregate between hours travel, between the time and the distance, because if you think about it, for a track load, they will do the same route back and forth. The distance will not change, but the time they spend on the network, on streets, is going to increase. So it's interesting, like when you're looking at speed, speed tends to affect tours in a very different way. And you need to start differentiating between distance and time. And obviously, if you have time windows, congestion is going to be bad in two aspects. One, obviously, reduces the speed, so you can serve less customers. But two, it makes your delivery times more unreliable, so you need to start adding buffers. You need to make your routes less efficient to accommodate for uncertainties in the travel time. So there's a big 3++ signs, like means that it's really, really bad for time window deliveries, changes in congestion, increases in congestion. So since congestion is so important, I'm going to just briefly focus a little bit on how congestion impacts on this type of tours, the ones that are related to time windows and the tour duration. So obviously, this issue about congestion is related to reliability. So congestion implies a loss in reliability. So implies a loss in being able to meet the demands of your customers from the carrier's point of view. So there have been a lot of literature on the issue of congestion, a lot related to how much it costs to passengers, to how much it costs to businesses. But there is no much, I would say, there is nothing, I think, related in academic journals related to how congestion affects carriers and carriers' costs. And this is what I'm going to be addressing here. So the same framework I had before still applies, so it's still analytical, but here you need to incorporate this concept of buffers, this extra time you have to allow to meet your customers' demand and to allow for changing travel times. And you need to somehow start modeling this stochasticity with randomness in the travel time and in the network. And the formulas start getting more complicated, not too much, but if you need to think about the same formula we had before, you need to start thinking about your tour duration will be reduced because you will be adding a buffer that will be related to what kind of customer service you want to provide. If you want to provide 99% deliveries on time, your buffer time will be very substantial. If you, as a company, want to provide 90%, your buffer will reduce substantially. So That's what is in red on the right. And then obviously, if you, for example, assume some normal distribution of travel times, you can start coming up with some nice ways of quantifying how the accumulated unreliability as you move through a route. Because you need to think about tours, so you have to think about many trips, and you need to think about, well, if I want to schedule 6 customers in a tour, how the travel time and reliability of the first 5 trips is going to affect the last customer. So there is an accumulating effect of uncertainty that you are accumulating as you are completing your tour. And the thing is, obviously, the last customer is going to be more exposed to changes in travel times because they have the risk of many more things going wrong throughout the day as you are servicing the other customers. So you can express this in a nice analytical form if you start using normal assumption of distribution of travel times. I'm not going to go into detail. But you see there the term that there is this coefficient term that relates to correlations, and it's something that is usually never taken into account. At least I haven't seen it in the literature. But correlations are very important because if you think about there was a delay going from A to B, it's very likely that if there was congestion at the time and you have to serve a customer for 5 minutes, when you are going B to go to customer C, there is still going to be congestion around there, and it's going to affect your travel time. The bad news is correlations make the issue of unreliability even worse. So usually it doesn't help. It makes things even worse because it accumulates the probability of, increases the probability of many things going wrong at the same time. So I divided 3 different scenarios, looking at changes in travel time, looking at changes in travel time variability, but no change in travel time, and then the combination of the two. And looking at the time, I think I'm going to skip some slides, but just to go to the more important findings and some formulas. But the important thing is, as you add congestion into the system, the percentage of travel time driving and the percentage of tour time driving are going to always increase. No matter how you design your routes, this is something that is always going to be the case. And this is important when we are going to show you later on some real-world data about congestion and tours in urban areas. So let me go here to when you have change, a reduction in travel time, an increase in travel time and an increase in the variability of the travel time. What is important to observe, and you can see this analytically, is that the compound effect of reduction in travel time and increased variability is really much, much worse than each of them isolated. So putting the two together, it really increases substantially, and we're going to see some numbers later on, the number of miles traveled and the number of hours on the network. And this is important too. You can see from analytical results that what is really bad is to have congestion, obviously, in the long links. So usually what is really bad is to have the congestion on the links, for example, between the depot and a customer delivery area, that it takes a substantial part of your tour. The importance of this is, in reality, that happens for many companies because obviously depots have to be located away from urban areas, away from downtown. So they tend to be far away. So there is a substantial connecting distance between the depot and the customers in many cases, and usually these connecting distances in an interstate, in one of the main arterials or one of the main highways. And unfortunately, these are the highways that tend to be congested and tend to have unreliable travel times. So what it says is that in practice, it's the worst situation when you have long distances to your customers, and that link is congested or it's very unreliable. And unfortunately, given the layout of most cities and the location of most distribution centers, this is usually the case. So in general, distribution companies are in the worst possible situation because they have to be far away from their customers. So looking at some nice conceptual way of putting all this together, the distance from the depot from numerical analysis and from the analytical study is very important. So how constrained your routes are, how demanding your customers are, is the other main concern. So if you combine the two, you can go from this combination of short distance to the depot and low constraints, so easy to satisfy customers. The congestion impact is going to be very low, even if there is a huge reduction in travel time. But as you start moving along from up left, you go down to the right, the number of routes that you're going to need is going to increase almost exponentially. And there is a point where it's not feasible anymore as you're getting too far and the congestion is really increasing. So what happens, and this happens in practice, is, well, companies have to start setting up more depots or distribution centers because they cannot reach their customers anymore when you have highly congested urban areas. So the issue is, once you get to the point, up to the point where companies establish new distribution centers, the increase in the miles traveled and hours traveled is really, really substantial. Obviously, once you start increasing the number of depots, this reduces drastically, but obviously the transportation cost is going to increase substantially for the company because now they will need to duplicate or have 3 facilities. So the fixed cost of providing services is really increasing substantially. So there is a clear trade-off between a shift of cost between the provider and the cost to society in terms of congestion produced by these distribution centers and companies. So these are just some numbers to give you an idea about these changes. And here I have on the left the average tour speed. So going from 50 to 25 to 12, so a reduction in speed of 2 and 4. And then going to the right, you have the coefficient of variation, so how much uncertainty you have in your travel time. And then I have here the total increase factor in cost. So I plugged in some real cost factors from a case that I got to study, and comparing with the case of no congestion and 50 kilometers per hour, these are the increases in the transportation cost. This is just the cost associated with drivers and with fuel. So if you look, it goes from an increase in uncertainty when you have relatively high speeds, 1.01, 1.02 is just 2% increase, is nothing. But as you are compounding that with a decrease in speed, getting to 33%, 50% increase in the cost, these are just operating costs. And obviously, when the reduction of speed gets really, really bad, then the increase in trouble in the cost, this is just fuel and driver time, it went up 6 times. So here, the level of uncertainty is very important. So it's the combination of increase in uncertainty and reduction in travel speed, what it really makes it really bad for delivering company. The other three columns, I look at what is the proportion of each cost in the total cost of delivering the service. So one is the cost of service time, so how much time the driver has to spend at the customers. So they have to spend half an hour. There is half an hour of driver salary that has to be paid because the driver is being paid. That is just to provide the service, to deliver the things or the service to the customer. The other column is what percentage of that salary is allocated just to drive on the network. And the third one is just how much is being spent on fuel. And obviously, I had to accommodate for the fact that the fuel efficiency is going to be changing as you change the driving speed because vehicles are less efficient. So I took that into account. And again, using real numbers, this is what happens. This is having an average half an hour service time per customer. You see at the beginning when there is no congestion, the service time, the time spent at the customers accounts for 60% of the cost of providing the service. As you start moving down and you get into the congested situation, you see how driving time and fuel end up taking 90% of the cost. So it's a huge change in the cost structure for the delivery company that obviously as you get into congestion, driving time and fuel are much, much more important. And it gets even worse because in some companies, it depends on how the type of contract you have. But if you have to pay overtime to the drivers, and overtime is more expensive than maybe 8-hour regular pay rate, it gets even worse. And this one is without overtime. But overtime can make it even worse in the sense of driving time, how much is as a component of the total cost of delivery. So just going to show you some real data, and this is from a company when I was in Australia, in Sydney. It was a company that was located at the port. It was a freight forwarder, so basically they break up containers that arrive from the port. They will get them to their distribution center. They will break them up into 5, 10, 15 customers that had small shipments inside the container, and then the next day they will deliver. So they were basically doing less than truckload with the cargo that arrived the day before. And obviously, the cargo and the customers will change every day. So one day to the other, it will be totally different, the stops and where you're going to go, because obviously each container is different. And even though there is some repetition of customers, there is no regularity or there is no certainty. And this is fairly common in delivery companies. Unless you have fixed routes, your demand is very, very, very random. So looking at some tour data, and here I plotted the tour data looking at two things. What percentage of the time the driver in that tour was driving. So here, going to the bottom, you have tours where the driving time was very low. Going higher, you have tours where driving was the most important component of the tour. And then at the bottom, you have the average distance per stop. So given a tour, it's a measure of kind of efficiency in the sense how many kilometers or miles you have to travel to serve each customer in that tour or route. So as you're looking at the data, there are things you can classify these tours. One, obviously, these tours that I call class 1 at the bottom tend to be very efficient because you have many customers and you have low travel distance and you have low percentage of the time driving. So these are the tools that are not very susceptible to congestion because you are close and most of the time is spent doing service time to the customer. If you go to those that are higher up but they're still close to the depot, what is happening is, given that the demand is random, sometimes you cannot have nice routes and you end up having routes that they are not very dense, and just because you couldn't accommodate customers in more tight, better designed routes just because the demand is random. And then you have customers that are located far away and you have to serve them no matter what, and this is the result. There are, per customer basis, they tend to be long distance, and looking at the tour time, driving is very high percentage of the time. It's just driving to get to these customers, do 1 or 2 deliveries, and come back. So obviously, these are the ones that are really the most expensive and the most susceptible customers to congestion, because as congestion is getting worse, those customers eventually, if it gets very bad, it will become infeasible because there will not be possible, there will be an infeasible region that will cover those tours, and you either have to give the cargo to another company or have to establish a new depot distribution center just to deal with these customers. So I'm going to wrap this up, and one thing about the conclusions is it doesn't make sense to look at urban freight just thinking about trips, because most companies think about routes and tours, and that's how they operate. And I know for planners, freight planners, it's nice to think about trips, makes the life easier, but this is not how it happens in reality. So one point about that, and obviously the different type of activity and the different type of constraints are really going to change how these tours are going to be affected by policy changes or changes in the network. And then finally, relating to congestion, this issue about distance between depot and customers and how much time is spent on the network is really important, because you need to think, one is bad, obviously, for carriers because their cost increase, but you need to think also is the worst combination of having low travel speed, high emissions, and a huge number of increased time on the road. So the negative impact, the externalities of congestion in tours are really significant, because you get the worst combination of increased in travel time, increased distance, and lower efficiency in the engines, because the engines are not working at the speed they are supposed to work to minimize fuel and emissions. So I'll stop it here, and these are some papers that are related to this. Got it from here, and you can get them at my website. And I think that's all. So if you have questions.
Yeah, so time for questions now, and just a reminder to use your microphone since we're on the web. So.
I'll throw out a question from one of our web viewers. And this is actually sort of going beyond sort of what you've covered in your presentation. But someone watching was wondering, or hypothesizing to some extent, that as deliveries become more time critical, it seems that drivers are under more pressure to make on-time deliveries, and that could increase accidents, which has an effect on time, obviously. Have you seen any relationship?
I have seen studies about the level of stress of the drivers and having to meet deadlines and congestion. I haven't done any work on that, but I have seen it. And if that person maybe mail me, I can.
What does some of that say?
Well,
is there a relationship?
There is, I think there are, depends who is looking at the data, there are different opinions. So I think it's still a lot of debate on that, if there is a real influence or not. I have seen the two sides. Obviously, some people say it's really bad. Some people say it's not really affecting that much. But again, it's not really my area of expertise. So.
Can you go back to the slides before the conclusion, talking about the relationship between distance and how many customers? Yeah. So I remember in the past we read some research talking about actually for short distance trip, it's more subjected to congestion and delay. Like a regular 20-minute commute, maybe it's more often for them to have like 10 minutes delay. But for regular 1 hour daily commute, maybe they also see 10 minutes delay. So the degree of sensibility for those kind of trips subject to congestion is different. It's more like short trips is more subject to the roadway condition. So are there any study talking about the locations of the customers?
You mean you're saying that short trips are more affected by congestion?
Yes, maybe something to do, for example, urban area may have more customer bases. That's why you make short trips. And the rural area, you have long distance trip.
Yeah, but this is all in an urban area that is all congested. So, I mean, you have to think about Sydney. It's a huge 5 million people city. And they were just covering deliveries within an area that is all urban and all congested. So I think it's obviously if you go to suburban or rural areas, yeah, the longer the distance, the faster you go because you will not find congestion. So, but I think it's a different kind of situation in this case. Yeah. Yeah.
Have there been any studies done on reducing the cost by using alternatives to fossil fuels?
There are a lot of studies, a lot. I mean, might be 1,000 studies. So, and there are a lot of new studies dealing now with the change in California is pushing for changing the fleets of, you know, the type of truck that are going to the ports, and they are retrofitting the engines and actually forcing the companies and the drivers to either buy new trucks or get more efficient engines. And there is a lot done about that and how much better it would be to have biodiesel or other things, yeah. But again, it's important to link travel speed with emissions and the type of engine and the type of fuel. So it gets very complicated very, very soon. So there are many, many variables that are involved in that situation. Yeah.
Just as they have high occupancy vehicle lanes for commuters, is there any talk in some urban areas of perhaps providing either commercial vehicle lanes or routes that they'd get preferential treatment so they could keep their travel time down?
Yeah, there is a lot of talk about that. There is also the issue about should trucks pay for using this or not. And I think that's the critical issue because obviously, like I said, there are many different commodities, and FedEx or Dell Computers, I talked to them and they were saying, well, we'll be happy if we have to pay something if we can make it on time and we can go faster. But obviously for the transportation companies that deal with bulky, low-cost commodities, they don't want to do anything with this. So I think it's even within the industry, it's really divided, the approach. And there are even more radical solutions than that. In Japan, they have consolidation centers where companies, just a few companies can operate, and they have to consolidate everything before they can distribute. But obviously, you have to think about Japan, the density and the streets. And but obviously, well, they have been forced to do that in some cities. But you cannot even think about forcing companies to, consolidate. Here, I think it would be still far-fetched. Yeah. Anything else? Yeah.
I have another web question. To what extent do distribution companies plan their services to avoid, the most congested periods, and what impact, does that have on costs and how they operate?
They plan as much as they can. The problem is most customers, well, they want to have early deliveries, morning deliveries. So if you look at statistics, 70% of the requests will be, I want a morning delivery. And that's what makes it hard, because then even if you leave the depot very early, you can leave at 4 in the morning. But is someone going to be at the consignee to receive the load at 5:30 in the morning? So can you drop the delivery, or who's going to be liable if something happens? So there are issues where companies could like, for example, to do more off-peak, but sometimes customers do not have the facilities or the time or the employees to be able to receive deliveries during off-peak hours. Yeah.
Are you aware of my idea of any delivery or companies on the freight side that are maybe using pricing? So in other words, charging their customers more for that morning, high demand time, but saying, hey, if you're willing to take it at, 1 in the afternoon or whatever, I'll knock off some cost.
That can work with some customers that are not time sensitive. So again, it depends the type of service or product, but many customers will really have to be very, very substantial, the change, to really make them budge a little bit. Yeah.
So are there any models or softwares that provide calculations for that thing for delivering products in a timely manner and avoiding
There are a lot of software companies that they advertise they have the best. The thing is, in reality, there are very few software and even algorithms that can take into account changes in travel time. I'm not even talking about unreliability, like making it stochastic. It's beyond the computational and the modeling right now, state of the art. So there are many companies that offer products, but the level of complication of you need to think about sometimes is you have many different vehicle types, you have many different type of customers, you have drivers that can drive certain vehicles but not in others. So the routing and scheduling tools are good, but the problem is there are so many constraints that adding travel times and stochastic travel times, it's very, very hard to do this. So it still is done kind of, it's still an art in many cases how to do this route.
So before we thank our speaker today,
Leah?
Does the fact that urban freight has to have such a high impact on congestion, is that recognized by transportation entities, and are there taxes higher for registering commercial vehicles for freight transport? I mean, for that specific reason.
Mm-hmm. Well, I guess that's a complicated question. If it's recognized or not, I think it would depend on the city and the state. There are some states that do care more about freight than others. I don't want to name anyone, but And the issue about registration and taxes, it's also changing so much. It's at the end, well, what the industry would say is at the end, you can charge us more. The consumers will pay eventually. So I guess I don't feel qualified to answer that question. But, yeah.
Okay, so our speaker next week will be Zong. All right, last question.
I'm just curious, are there places where congestion has gotten to a point where it's so bad that they've actually crossed into the infeasible region, like where really unless you're within a 3-mile radius, it costs too much to ship something?
Well, that really is very location specific, and it depends on the time of the day and the specific location of the depot and the customer. So I'm sure there are situations where companies have to expand and add new facilities, so they have to subcontract other companies to take care of some of the shipments they cannot accommodate anymore because there is congestion. But you need to think that it's not easy to get this kind of information because obviously companies are very private about the data. They don't want to share because it would affect customers, and obviously it's very hard to get real data to say, well, this is happening here for this kind of location. But it's if you talk in private with companies, yes, that's an issue that obviously increases their cost substantially. They have to increase the facilities, or they have to hand demand to other providers. Yeah.
All right, so next week's speaker is Dr. Zong Tian from the University of Nevada, Reno, talking about the analysis of closely spaced traffic signals. So with that, let's thank our speaker.
Thank you.